Hello, my name is Mario Duenas, and this is my lab report for Lab 2, where we tested projectile motion. As mentioned, the objective of this lab was to record and observe the motion of an object that is thrown and moves like a projectile. Essentially, we wanted to see how the force of gravity impacts the motions of an object. The applications used during this lab was Tracker and GlowScript. We also used a bit of Excel to record our data and also make graphs out of it. The predicted curve that was found went out further in the x direction than the observed data in Tracker, although the y distance seemed pretty consistent. The drag found barely affected our curves as well, and this led to inconsistencies in our findings and our predicted findings. The variables in this experiment were found based on the video we put into Tracker. The initial position was when our axis intercepted at y. Because of this, we got the following vector. For initial velocity, we found displacement in the x and y direction over the first time frame and got this vector shown on the screen. Our mass was 0.01125 kilograms and our gravity was 9.8. For force of drag, we needed to find the B coefficient. But what exactly is B? Because of this, we found out that B was 0.000136, and it's derived from cross-sectional area of the ball, the mass density of the air, and also the drag coefficient based on the object shape. Because of this, we use 0.47 for a rough sphere. We use 2.5 squared pi for the area of the ball, and then we use 1.18 for the mass density, as that's the average mass density in Georgia, or more accordingly in Atlanta. The following video was used during our experiment in Tracker.
I'm recording.
Using Tracker, we tracked the ball's position as it moved through the air using the video. We used a meter stick as calibration as it was set up in the video as well. We then tracked the object's position frame by frame and recorded the data that it was produced in Excel. The following graph was also produced in Excel and displays the observed motion of the ball and how it moves as time progresses in X and Y direction. Using the data we found in Tracker, we created code in which we plugged in the object's initial position and the object's initial velocity. We also plugged in the object's mass and also assigned the variables for F net, which is equal to the force of gravity plus the force of drag. The force of drag gave us this complicated equation, and then the force of gravity was simply the vector 0, negative ball m times g, 0. This was then later plugged in and gave us this graph, which compares to the other previous one shown. After having access to both data tables in Tracker and GlowScript, we plotted both data tables on one graph to see how the observed versus prediction motion compared. In our results, we found out that the prediction motion went further in the x direction compared to the observed motion. However, in the y direction, it aligned pretty neatly. Some errors that could occur is the shifted camera angle, the wrong B coefficient in case we calculated that wrong, or not starting from the table surface. To begin answering the questions at the end of our experiment, we must understand that not enough time or height was achieved to produce terminal velocity. In order to replicate this experiment with terminal velocity, we would have gone higher and have more time for the drag coefficient or the drag force to catch up to the force of gravity, producing a net force of 0. If the object was initially thrown straight up with the same initial speed, that would mean all the speed is in the y direction, giving us a longer time we have to wait for the object to come back down, as there's more velocity in the y direction. The y direction now has the velocity of the x direction, only now it's only one-dimensional.